What are the other cranial nerves that are involved? So this ENT surgeon, we deal a lot with cranial nerves because we have a neck and that's where they exist more or less. The trigeminal nerve mediates a sense of touch. The touch is not just what you think of when you put your finger on the table. You can feel that you're touching the table. What you're feeling there is actually a complex set of sensations. You can feel a light touch and then a deep pressure touch. You can perceive pain, you can perceive temperature, and all those things are mediated in the head and neck by the trigeminal nerve. So the nose, for instance, has cold receptors that sense the cold air coming in or out. It has, and they can be stimulated by chemicals. So in menthol, the opening sensation of a menthol sweet doesn't actually make any difference to the volume of your nose inside. It just, because part of the way that your nose tells whether it's open or not is through activation of these cold receptors. The menthol chemically stimulates those cold receptors and tells you that it's open even though it makes no difference to the air at all. So that's one form of touch. Capsaicin, what we call hot. In some cultures, actually, that's considered another type of taste, but it's probably direct stimulation of pain receptors, unsurprisingly. So that's, again, that can be true in the nose as well as in the mouth. So, for instance, a lot of people who come to me saying, I can't smell anything, will often say, but I can smell petrol, or I can smell some other things. And these are always vapors of acrid materials. And that's probably also a type of pain stimulating the trigeminal nerve rather than a true smell. But all of these things can be used, again, to increase your perception of food and your enjoyment of things in the environment. Trigeminal nerve also mediates what food scientists call mouthfeel. So the texture of food in the mouth is very important. For instance, the way you tell whether crisps are fresh or not turns out to be the amount of snap that they have in the way they break in your mouth. And you can mimic that by playing people the crackle in their in headphones while they're eating stale crisps and they think that they're completely fine. So that mouthfeel, the snap, crackle, and pop, also mediated by the trigeminal nerve. So that's touch. And then the third part of our tripod of things that go towards human sensation is taste. Now, taste is mediated by two nerves. The facial nerve, a branch of it, head and neck anatomy is bizarre. The facial nerve has a tiny little branch that crosses across the eardrum and then hitchhikes down a nerve called the lingual nerve to supply sensation to the front part of the tongue, anterior to the third. And then the glossopharyngeal supplies the other part of the tongue. Why we chose to do it that way, I don't know, but that's the way it is. And you've all seen the taste map of the tongue where you get sweet at the tip and salty to the sides and sour. It's rubbish. And loads of myths about taste, and I'm here to explode all of them. It's probably just a mess. Certainly there are gradients in terms of the concentration. So bitter does increase as it goes back, but there are bitter receptors right at the front of the tongue. So don't believe that. And additionally, those canonical four flavors aren't the only ones that we have. So we've got sweet, salty, sour, and bitter. Everyone knows about those. But recently, and this is becoming more and more widely known, the sensation of umami, which is the Japanese word for kind of the broth, the meatiness of a broth. It's really glutamic acid. So sodium glutamate directly stimulates a different type of receptor, the glutamic acid receptor, which is an additional receptor. So there are at least 5. In rats, there's an additional 6th one, which just detects free fats, and it may be true that happens in humans too. Certainly, fats change the mouthfeel by the trigeminal as well. So there are at least 5, not 6. And all of these are going to interact together. I'm not even going to go on to how they interact in the brain, but suffice to say that they all overlap and give you this holistic percept of human sensation, of flavour, and of understanding the environment, or the chemical makeup of the environment. So that was a whistle-stop tour through through what we were supposed to be talking about, chemosensation. I hope that's laid the groundwork for what Carl and everyone else is going to talk about later on. And do you have any questions?
Yes, I've got a question. Mine is David. Something you said triggers some thought.
Oh, can I just say, before I've had 2 hours sleep and I have last week because I've had 6 children, so if I don't make sense, I'm sure the bar apologize.
How cells are being replaced regularly and the brain has to learn or doesn't know how to find the new one.
It doesn't have to, because the cells find their own one. That's the code.
But there's recent research been reaching into the more general press about DNA methylation and how, certainly we think we understand how that affects imprinting, but there appears to be evidence that evolution has allowed a process within a particular genetic makeup for a population to perceive, or for a population to have genetic activity which is different because of random changes in methylation.
Okay, yeah.
So my loss of sense, I think, is associated with viral infection. Could that viral infection actually have been changing that rather arbitrary methylation process? So my replacement cells are having different protein generated, and that brain recognition process is missing out.
That's a good question. I've never thought of that. What I do know about viral infections is that when you look at the biopsy studies that have been done looking at this, and it seems there's a direct viral infection of those nerve cells. I've always assumed that once you destroy the tracts of regeneration, we don't know how that targeting works. There are theories, but nobody really knows. And so once you destroy the lining cells, the glia, through this very exuberant inflammation, I assume that's then the nerves don't know where to go, and you just get this tangled mess when you look at it under the microscope. Whether or not that's due to methylation, I don't know if anybody's applied that to targeting.
An area for research.
Yeah. As you're going to see today, there are.
One for the list, something?
There's a lot of work in mice at the moment about how the neurons know how to make connections. And I know when there's a lot of damage, it becomes a very tangled picture. But when they're looking at just what happens in the normal process, mice who don't get to smell anything don't know how to organise these neurons. But if they're smelling things and learning to smell, the way that they organise them and the turnover is much better. So it seems to be about how much input you're getting into the brain and how they're training themselves to organise, and also how the body is getting rid of the old ones so the new ones line up properly. So it's an area that's the forefront of knowledge at the moment. As I said, we don't know, but people are looking at it.
Well, I think the smell training is starting to have an effect on me. Back off from that. Thank you, anyway.
Thank you.
I was interested to say about the trigeminal. You said how things like smoke and petrol. How does that get translated into smell? It's just the
Well, it's more an irritation, so it's a sub-pain threshold. But it isn't a smell, but you perceive it as just being irritation coming from your nose. So we didn't go through what happens in the brain, but all of this gets summed up in various areas. And obviously, if you've learned through your childhood to call any sensation in your nose that is obviously pain a smell, then that's what we call it. So all of this, that's what my whole this diagram question is. This overlapping thing, when it gets to the higher centers, just gets bundled together in ways we still don't quite understand into something called a percept, where although you might be able to divide it up and say, oh, that's that taste plus that smell plus that mouthfeel, when you're perceiving it, you don't get that. You go, oh, that's peanut butter.
I think with something like petrol, there is a lot of its sensations and trigeminal, but there's also an olfactory component as well, which also has an odour. Because I can detect the vapour of petrol, the trigeminal effect, but it doesn't have the smell for me that it used to. And there's probably lots of things like menthol, for example. You know, I don't get the sense of mintiness, but you still get the sensation of the tingling in the nostrils. It's like Simon said, it's to do with there's lots of overlap.
One quick question. Can you explain the fact that some of us, I believe I'm not the only one, get extra smells? And suddenly I have this feeling, I walk into a room and say, oh, it's burning here, it's burning.
So I have a theory about that. I don't know if you're Carl agrees. I think burning is a very interesting smell. Because if you look at burning, there are a huge number of chemicals that are produced by the burning reaction. They're partially, there's lots of heat, lots of carbon, making sort of various chemicals. And I think that means that when you smell something that's burning, that's when that's a sort of global activation of a lot of receptors. That's what we call a burning smell. And there are sort of anecdotal evidence about people approaching a burning tire, and forget where it was, but the person who was writing about it describes the smells that wash over him as he's getting to it. And he's trying to work out what it is, and at first it's quite pleasant, and then there are these other smells, and then they start building up, and finally it turns a corner and he realizes this is the smell of burning rubber, which is a very unpleasant smell. And I suspect that it's a widespread activation of all of those glomeruli that we call burning. So it may be that various ways that this happens. We think that there's a form of epilepsy which affects the olfactory bulb, and maybe just disorganization and sort of general, there's certainly almost as baseline activity, whether in your nose there's that baseline activity just suddenly crescendos for no very good reason, or whether it is a form of epilepsy, and whether there's a disorganized generalized fire in the nose. I think that also explains why people talk about smelling burning toast when they're struggling.
Do you have any theories about phantom smells that don't seem to have any origin and they linger for days and days?
Yeah, so you always have to rule out the fact that so bad smells can actually be there, and just from the sinuses, for instance, or dental infections and things like that. But again, this persistent activation through some kind of electroform process, I think we don't know anything about it. We don't really have ways of looking at it at the moment. But that's my bet. That's my theory.
Can loss of hearing affect the smell and taste?
Yes. Depends how you get it, obviously. But there's certainly in mice there's something called sound, which is the overlap between smell and sound. And it seems that they've shown that it does.
I lost my hearing,
yeah.
And then I lost my smell and taste.
So again, you have to look at there could be one disease process that affects two separate nerves, or it could be affecting nine centers, things like that.
I have genetic evidence in my family, it could be a carrier. Could that be what's causing my loss of smell? It's in 26 proteins.
Syndromic associations?
Not obviously, no. I guess there are potential some sort of genetic disorders which will be very sensitive. That's unlikely.
But it depends on the gene.
I think going back to Simon and then David's point as well, I think even in the space of 5 minutes there, how many possible topics have we covered? Researched in massive detail, it's absolutely. I mean, this is the thing you see, I've become so fascinated by something that I'm no longer even in possession of. It's If only I'd given more of a toss about it when I went. I'll probably stop questions there if you don't mind. So I'm just conscious of time, and also we've got a lot to fit in. But Simon, can I just say thank you very much.